Make sure we're still on the screen. Yeah. So I have what? T is equal to 6 minus square root of 10. And T is equal to 6 plus the square root of 10, okay? Now, I want to put those on this number line here, but I don't know where they go exactly, okay? So what I'm going to do is take a calculator and get an approximation here. What is 6 minus the square root of 10? 6 minus square root of 10 is about 2.83. And 6 plus the square root of 10 is about 9.16. So let's plot those. Where is 2.83? 2.83 is somewhere right here, right? But its actual value is 6 minus square root of 10. How about 9.16? That's somewhere way over here, right? I'm out of room, but maybe I'll put it there. And I'll call that 6 plus the square root of 10, which is about 9.16. All right, so what do we do now? We're going to run test values here, here, and here to see if this acceleration is positive or negative. And actually, I would encourage you to just put all that in your calculator, okay? For example, you can take a 1, put it in for T here, here, and here. Remember the quick way I showed you on the calculator, that video on Moodle? You can do that, okay? And let me just go through that, okay? I don't feel like bored, with that. We get pluses right here when we do it. We get minuses right here when we do it. And we get pluses right here when we do that. Now take your velocity function, which I had to erase, and do the same thing. Do test values here. And you'll get like negatives here. You'll get positives here. And you'll get negatives there, okay? So let's see. What are we looking at then? We're looking at, for this part, where's the particle speeding up? Where is it slowing down? So where's it speeding up? And where's it slowing down? All right, so what happens right here between 0 and 2? We have what? Opposite signs, so it's slowing down. So my particle's slowing down whenever t is between 0 and 2 seconds. Now what happens in this area right here? Okay, these were positive, right? Acceleration between this value of 2 right here and this value is 6 minus square root of 10. My acceleration is positive and my velocity is positive, so my object is speeding up there between 2 and 6 minus the square root of 10. Between 2 and 6 minus square root of 10 seconds, my object is speeding up. Now what happens between 6 minus square root of 10 and 4 seconds here? Velocity is positive, acceleration is negative, so it's slowing down between 6 minus square root of 10 and 4 seconds. Between 6 minus square root of 10 and 4 seconds, we're slowing down. Now what happens between 4 seconds and this part? 6 plus the square root of 10 seconds. Same sign, so we're doing what? Speeding up again. So between 4 seconds and 6 plus the square root of 10 seconds, we're speeding up again. Now, what continues to happen here? Past 4, we get negatives, right? So what happens beyond 6 plus square root of 10 seconds? Opposite signs, so we're doing what? Slowing down. So we're slowing down when t is greater than 6 plus square root of 10 seconds again. There's where my object's speeding up, and then where it's slowing down. All right, part C. Ooh, we're still not done with this problem, huh? Part C says, find the total distance traveled from t is equal to 0 to t is equal to 5 seconds and round your answer to 3 decimal places. Find the total distance traveled. Total distance traveled. Let's see. So what happens here? If I think about the graph of my position function, here's S, here's T, right? Well, where do I start? From T is equal to 0 to T is equal to, what did we say, 5 seconds? So where we start is we plug in 0 into my position function to find out where I'm at position-wise at time 0. So S of 0 is equal to 0 squared plus 8 times e to the negative 0 over 3. Well, that gives me 8 times, what's anything to the 0 exponent? I can't say anything, any number to the 0 exponent. What's that? 1? That gives me 8. So that means at 0 seconds I'm at 8. 0, 8. All right, let's see what else we have. What's my graph going to do? It's either going to go up or go down until it hits a critical point. Then it's going to change, right? Where it has a relative max or min. So where does that happen? Where do I have critical points? Where my first derivative is equal to 0. What was my first derivative? Velocity, right? Where was my velocity equal to 0? Well, we found that earlier, right? We said at 2 and at 4 seconds. So I'm going to need to plot a point at 2 and a point at 4. So let's evaluate S at 2 to see where I'm at. S at 2, that's equal to what? 2 squared plus 8. 2 squared plus 8 times e to negative 2 over 3. And this wants me to round at the end anyway. So if I do this calculation and I round, I'll have to put it in my calculator. Sorry for boring y'all with this. I didn't have it set up ahead of time. So let's see. What do we have? T squared plus 8. E to the what? Oh, this makes incredibly boring videos, by the way. Negative t over 3. And what do I want to do? I want to evaluate it at 2. I got something like 6.1610054. All right, so at 2, I'm at 6.161. 0, I'm going to say, okay? But I need a point at 4 as well, right? So I'm going to evaluate S at 4 and see where I'm at. S at 4 is what? 4 squared plus 8 times e to the negative 4 over 3, right? So let me see where I'm at there. I got approximately 6.32633313. So what does that mean? That means at 4, I'm at 6.3263. And what else do I need? Okay, what's going on so far is I have a graph that might look like this. I don't care if it looks exactly like that. I'm just using this to find my total distance traveled. So what I do, I plot it where I start, 0, 8. I plot it where each one of my critical points were. Now I need to plot my end point at 5. So let's find S at 5. So S at 5 gives me what? 5 squared plus 8 times e to the negative 5 over 3, right? Let's see what that gives me. About what? That gives me approximately 6.2328949. So it means over here at 5, I'm at 6.23. 5, I'm at 6.233, I could say. So my graph does something like that. Whew! How am I going to find this total distance now? Let's see, total distance. Not going to be pretty, but guess what? Real life sometimes isn't pretty. All right, output minus output in absolute values is 6.1610 minus 8 plus absolute values output minus output, so 6.3263 minus 6.1610. So got this distance, got this distance, I still need this distance, right? So plus distance, we're going to use absolute value. Output minus output. 6.233. I don't know why I didn't carry it further, but anyway, y'all got the picture. Minus 6.3263. And if I calculate all that and I round to 3 decimal places, I get something like, let's see, 2.0978 or approximately 2.10. And what is this measured in? Feet. I'm not real confident in that. Let me check myself because it was kind of scribbled in my notes. So let's see.